Could 3i Atlas actually be alien technology? That's the question shaking astronomy right now. An object from another star system has drifted into our solar neighbourhood, and the deeper we look, the stranger it gets. Some call it the third interstellar visitor ever detected. Others whisper that it may be the first artifact of another civilization we've ever seen. Let's start with the raw numbers. 3i Atlas is massive. Not just big for a comet, not just big for an asteroid. Astronomers estimate a minimum mass of 33 billion tons. That's the floor, not the ceiling. To picture that, think of Manhattan Island carved in half and hurled across interstellar space, or Mount Everest compressed into a frozen projectile. This isn't a pebble wandering into our system. This is a mountain, a continent-sized traveller. Its size alone raises eyebrows, but the orbit makes the mystery deeper. 3i Atlas isn't coming in on some wild angle the way you'd expect a rock flung in from the galaxy. Instead, its path is aligned almost perfectly with the flat plane where our planets circle the Sun, the ecliptic plane. The odds of this happening by random chance about 1 in 500. Imagine a dart thrown across light years of space hitting bullseye on a moving target. That's the level of precision we're looking at. Then comes the physics that refuses to play by the rules. Comets outgas when they get close to the Sun. Ice vaporizes, jets erupt, and those jets push the comet off course. Astronomers call this non-gravitational acceleration. Every comet we've ever studied has shown it, except this one. 3i Atlas is venting gas. Our telescopes see the plume, but its trajectory doesn't shift. It stays locked in place as if guided. Like a ship sailing with full wind in its sails but gliding straight as if on rails. No drift, no wobble. Nothing natural does this. And then there's the chemistry. Observations show nickel in its surrounding cloud, but no iron. In the universe, nickel and iron are twins, forged together in stellar furnaces, scattered together in cosmic dust. To find nickel without iron is like finding smoke without fire. In nature, it just doesn't happen. But in human industry, it happens all the time. Nickel-based alloys are the backbone of jet engines, rocket turbines, heat-shielding machinery. Nickel without iron is not geology. It's engineering. Put these anomalies side by side, size too massive for current models. Orbit aligned too perfectly to dismiss as coincidence. A body that refuses to accelerate the way physics says it should. And chemical traces that look suspiciously like they belong to a machine, not a rock. Any one of these would be puzzling. All of them stacked together. That's not just odd. That's alarming. Of course, most astronomers are cautious. They remind us that extraordinary claims demand extraordinary proof. Maybe Atlas is just a rare natural monster. Maybe we've been unlucky or lucky depending on how you see it to catch 3 interstellar visitors in less than a decade. Maybe the universe just plays dice and sometimes the dice land weird. But if you talk to people off the record, you'll hear it. The quiet speculation. The suspicion that something about this isn't random at all. And that's what makes this story electric. Think back. In 2017, we had Oumuamua, a bizarre cigar-shaped rock that sped up as it left the solar system without a single puff of visible gas to explain it. In 2019, Borisov came through a more ordinary comet, but still interstellar, still strange. Now Atlas arrives. Larger, heavier, more disciplined in its path with fingerprints of metallurgy in its tail. 3 anomalies in less than 10 years when by all probability we shouldn't have seen even one in our lifetimes. It forces a question. What if these aren't coincidences? What if they're messages or probes? What if civilizations older than ours seeded the galaxy with watchers, and one of them just passed by our doorstep? It sounds like science fiction, and maybe it is. But the facts are here staring us in the face. For millions of years, humans stared up at the stars and wondered if we were alone. For decades, scientists scanned the skies for radio signals. SETI dishes listened for whispers that never came. And yet right now, actual pieces of other star systems are sailing through our backyard, carrying signatures we can't explain. No signal required, no invitation needed. The universe is knocking on our door in a way no one expected. The brain rebels at this. Our instincts kick in. Pattern recognition is our oldest survival tool. When bushes rustled in the dark, our ancestors assumed predator, not the wind, because false alarms are safer than missed threats. That instinct still drives us today. We see patterns. We crave meaning. And when a 33 billion-ton alien traveller shows up aligned perfectly with our planets, shrugging off physics, trailing the fingerprints of engineering metals, the pattern feels obvious. But science lives in the tension between wonder and skepticism. Harvard astrophysicist Avi Loeb has already suggested that if Atlas is larger than 10 kilometers, natural explanations collapse. There simply isn't enough material in interstellar space to explain its presence, and if it's not natural, we have to consider the alternative. That possibility changes everything, not just astronomy, not just science, civilization itself. So here we stand at the edge of a mystery, a faint speck in the night sky moving across the void, carrying secrets older than the Earth itself. In the coming weeks, spacecraft and telescopes will capture more data. They'll measure, they'll probe, they'll analyze. Maybe the mystery will fade, explained away by physics. Or maybe the opposite will happen. Maybe the evidence will sharpen, the strangeness will deepen, and the whispers of alien technology will become harder to ignore. Right now, we don't have the answer. We only have the question. And it's a question that strikes at the heart of who we are and what we believe about our place in the universe. Is 3i Atlas chaos a freak of cosmic chance? Or is it code, a design, a message written across the stars by minds not our own? Because the difference between those two possibilities isn't just academic. The difference changes everything. The first strange clue didn't come from a giant telescope on Earth. It came from space. Back in May and June of 2025, NASA's Transiting Exoplanet Survey satellite, better known as TESS, captured images of the sky. In those frames, astronomers noticed something odd. A faint object later identified as 3i Atlas was brightening. Not a little, a lot. In less than a month, its brightness increased 5-fold, 5 times brighter than before. For context, simple geometry should have given us only a 1.5-fold increase. That's the math. As Atlas moved about 0.9 astronomical units closer to us, it should have reflected more sunlight, yes, but nowhere near 5 times more. Something else was happening. This is where the mystery deepens. Because at the time, 3i Atlas was far from the Sun. We're talking about 6 astronomical units out roughly the orbit of Jupiter. At that distance, sunlight is weak, temperatures are frigid, and comets rarely wake up. Ice doesn't sublimate enough to drive big outbursts. In other words, there should not have been any dramatic flare in brightness. And yet that's exactly what TESS recorded. So what explains it? The standard idea is outgassing, that maybe Atlas was venting carbon dioxide or other volatile ices, releasing gas and dust that reflected more sunlight. But at 6 AU, it's simply too cold for that level of sublimation. The numbers don't line up. Astronomers call it implausible, which leaves us searching for another explanation. Here's the hypothesis that electrified the conversation. What if Atlas wasn't just coasting into the solar system? What if it was actively braking? Imagine a spacecraft firing thrusters to slow its approach. A ship from another star system tapping the brakes before entering the crowded inner planets. That's what some theorists suggested. The sudden increase in brightness could have been the result of controlled maneuvers, energy releases, or some engineered mechanism activating as it neared the Sun. Now let's be clear. There's no direct evidence of rocket engines firing, no exhaust plumes, no hot gas signatures. But the sheer scale of the brightening, 5 times stronger than natural models predict, forces the question. Why does Atlas glow as if it's alive when physics says it should be asleep? Think about how our own spacecraft behave. When Voyager or Pioneer fired thrusters, they vented tiny amounts of propellant. From Earth, those events were invisible except for the subtle changes in trajectory. But Atlas is massive, 33 billion tons at minimum. If something that large applied braking force even slightly, it might generate light curves and gas releases detectable across the solar system. The analogy is imperfect, but it lingers. We know what natural comets look like when they brighten. This isn't it. Skeptics counter with simpler answers. Maybe the models underestimated how much surface area Atlas has. Maybe its crust cracked open, exposing fresh ice that vented more efficiently than expected. Maybe we just don't understand the chemistry of interstellar objects yet. All valid points. But none explain why the brightening was so sharp, so sudden, so far from the sun. Here's where the story shifts from unusual to unsettling. Because the brightening didn't just hint at activity, it hinted at speed. If Atlas appeared to brighten faster than geometry allowed, one possible explanation is that it was closing in on us more rapidly than our instruments predicted. That means our calculations of its motion might have been off, or something altered its motion deliberately. Now picture it. A dark object from the stars racing toward the sun, suddenly flaring in brightness, as if it flipped a switch. For astronomers watching the test data, it was a wait-what moment. It felt less like a comet quietly awakening, more like a craft announcing itself. Even if you reject the alien idea, the data is still bizarre. Natural comets brighten gradually. They don't jump fivefold at that distance, and they don't do it while maintaining such a steady, almost mechanical trajectory. It's as if Atlas is performing, not drifting, acting, not reacting. Of course, mainstream voices urge caution. We only have a few weeks of brightness measurements from TESS at that early stage. Calibration errors, background star fields, and observational geometry could all play roles. But even after accounting for those factors, the anomaly doesn't vanish. It remains stubborn, glaring, and unexplained. So what are we left with? A choice? Either Atlas is a natural comet that just happens to be breaking all the rules we've learned from centuries of astronomy, or it's something else entirely, something designed, something maneuvering, something that doesn't want to play by the script of physics we thought we understood. The brightening of May and June 2025 is now burned into the record as the first red flag, the first undeniable hint that 3i Atlas might not just be a rock. It set the tone for everything that came after. Its impossible glow is the opening act of a performance that only grows stranger as this visitor continues its path through our solar system. And here's the question that still hangs in the air. If you were building a probe to cross light years of space, wouldn't you slow it down before it entered a planetary system? Wouldn't you control its speed to maximize observations or to minimize the chance of catastrophic collision? Isn't that exactly what Atlas looked like it was doing? This isn't proof, but it is provocation. A clue dropped into the night sky, a whisper from the darkness saying, "Pay attention." There's a term astronomers use when they study comets and small bodies' non-gravitational acceleration, or NGA. It sounds technical, but the idea is simple. When a comet gets close to the sun, heat makes ice vaporize. Gas erupts from the surface, jets of vapor push the comet, and the comet's path bends ever so slightly. It's like firing tiny thrusters. Every natural comet we've ever tracked shows this effect. It's textbook physics. But 3i Atlas doesn't follow the book. In fact, it tears the book apart. Let's look at the numbers. Oumuamua, the first interstellar visitor, had an NGA measured at roughly 2.5, 10 to 4 astronomical units per day. That's huge. It visibly sped up as it left the solar system, even though no gas jets were detected. Borisov, the second visitor, behaved more like a normal comet. Its NGA was about 10 to 6. Hale-Bopp, the monster comet of the 1990s, clocked in with 10.7 despite being truly gigantic. The Rosetta mission's comet, 67P Churyumov-Gerasimenko, registered the same order of magnitude, 10.7. Now comes 3i Atlas, its NGA about 10.8, 100 times less than Borisov, 10 times less than 67P. Even Hale-Bopp, a behemoth, had stronger non-gravitational pushes than this interstellar giant. Think about what that means. Here is a body venting gas displaying a faint anti-tail toward the sun, and yet the gas doesn't seem to push it anywhere. It's like watching a ship in a storm, sails bulging in the wind waves crashing against the hull. But the ship keeps sliding forward in a perfectly straight line, as if locked onto steel rails. Nature doesn't work like that. Not for comets, not for asteroids, not for anything we've ever measured. This is why scientists are uneasy. NGA isn't some optional feature of comet behavior, it's a rule. a consequence of thermodynamics and Newtonian physics. Ice turns to vapor, vapor escapes, momentum shifts. To see Atlas ignore this rule is to watch physics itself mocked in real time. The most conservative explanation is sheer size. If Atlas is colossal enough, maybe its mass swallows up the effect of outgassing. Jets push, but the body is so massive they barely matter. But the math is merciless. Even an object the size of Hale-Bopp showed clear deviations. For Atlas to be this steady, it would have to be unimaginably heavy, beyond what interstellar formation models predict. At that point, calling it just another comet stretches credibility to the breaking point. There's another explanation, a harder one to dismiss. What if Atlas is being stabilized? What if the trajectory isn't natural at all? Some astronomers have whispered this already. Controlled motion, artificial guidance, not an accident, but intention. That's a dangerous thought in science. To suggest control is to step into the territory of alien probes of spacecraft from other civilizations. The mainstream recoils at that leap. But the data doesn't care about comfort. The data says here is a body venting gas, and here is a body not moving the way every other venting body moves. Harvard's Avi Loeb has been blunt about it. He notes that the combination of size stability and alignment with the planetary plane makes natural explanations increasingly thin. The probability space for randomness is shrinking. What's left is a picture no one expected to confront. Now pause for a moment. Imagine how humans would design a probe to cross interstellar space. You'd want it heavy enough to endure impacts, stable enough to hold course, and when it neared a planetary system, you'd want control, the ability to resist random drifts, the ability to keep the path straight even in the chaos of gas and dust streaming off the surface. Isn't that exactly what Atlas looks like? The comparison to a train on rails isn't just poetic, it's painfully accurate. NGA is the sway, the wobble, the unpredictability of natural motion. Atlas has none. It barrels through space as if locked to a track. Of course, scientists push back. They insist that extraordinary claims need extraordinary evidence. They argue that we've only tracked Atlas for a few months, that longer data arcs may reveal subtle shifts we haven't caught yet. They caution against reading intention where only coincidence exists, and they're right to be cautious. But the silence of NGA remains, and with every day that passes, the strangeness only grows. We have precedent for strange behaviour. Oumuamua accelerated without gas. Borisov acted like a comet but carried odd chemistry. Atlas, by contrast, vents gas but refuses to accelerate. 3 anomalies, 3 contradictions, each different, each impossible. Together they sketch a pattern we don't yet understand, and that's why the whispers about control won't go away. If you strip the jargon away, NGA is simply physics keeping score. Cause and effect, push and response. For 3i Atlas, the push is there, the response is not. That breaks the contract between observation and prediction, and when nature breaks its own rules, either our models are wrong, or we're not looking at nature at all. This is the point where even hardened skeptics start to hesitate. They may not say alien technology, but they admit the words artificial control describe the data as well as anything else. A comet that ignores physics, a body that shrugs off forces that should bend its path. If that isn't controlled, what is it? Think of it this way. Every comet is a kite in the wind. Some drift gently, some jerk wildly, but all are carried. Atlas is no kite. Atlas is a drone. It cuts through the gale without swerving, obeying a logic we don't see. The mystery of NGA isn't flashy. It isn't as cinematic as a glowing tail or a fiery outburst. But among astronomers, it is the most disturbing evidence of all, because it's measured, quantified, hard numbers that refuse to go away, a straight line where there should be a curve, a silence where there should be noise. So here's the question that matters: is Atlas simply too big to budge a freak of cosmic chance? Or is it something else? A machine? A probe? A visitor on rails of its own making? We don't know. But the longer it holds its course, the harder that question becomes to ignore. When scientists pointed their spectrographs at 3I Atlas, they weren't just measuring light. They were dissecting the chemistry of a traveller from another star. And what they found was wrong. Inside the glowing halo of gas around the object, they detected nickel. Pure nickel, but no iron. That may sound trivial, but in astronomy it's a red siren. Out in the cosmos, nickel and iron are twins. They are born together in the hearts of dying stars, forged in supernova furnaces, exploded into the galaxy side by side. Wherever you find nickel, you find iron. Always. They are partners inseparable in the natural world. So when telescopes picked up the spectral lines of nickel without the matching signature of iron, astronomers had to double-check their instruments. Was it noise, a calibration error, a trick of the background? They checked again, and again. The nickel was there. The iron wasn't. That's not nature. That's something else. Here on Earth we break that rule all the time. Not in the wild, but in our factories. Nickel alloys are the backbone of modern engineering. They're in jet engines, in spacecraft, in turbines that endure heat so intense, ordinary metals would melt away. Nickel without iron is not cosmic geology, it's industrial metallurgy. So what does it mean when an interstellar object trails a signature of industry? Imagine seeing an oil slick spread across the ocean. You don't assume it's a natural phenomenon, you know it's the wake of a ship. That's how this felt. A smear of nickel in the void, a sign that something unnatural passed this way. The most provocative idea is that 3I Atlas carries the scars of machinery, that the nickel might be waste-eroded fragments from engines, superalloy components worn down after who knows how many light years of travel. Like metal shavings left on the shop floor, carried along in the exhaust of a working machine. It's not just science fiction speculation. Rocket engines use nickel-based alloys for strength at high temperatures. As they run, those alloys shed microscopic particles, often pure nickel as the structure wears. On Earth, engineers expect it. It's part of the life cycle of the hardware. But to see a similar fingerprint smeared across the coma of an object from beyond the sun that rattles the imagination, skeptics push back. Maybe the signal is misinterpreted. Maybe some exotic chemical pathway produces nickel alone in deep space. But here's the problem in all the history of comet spectroscopy and all the decades of studying hundreds of natural objects, no one has ever seen nickel without iron. Not once. So what are the odds that the third interstellar object ever found, already a once-in-a-lifetime anomaly, just happens to carry the first recorded case of pure nickel emission? Coincidence starts to strain under the weight. This is where the debate heats up. If you're conservative, you shrug and say, we don't know enough about interstellar chemistry. If you're bold, you say, that's not chemistry, that's technology. Think about what we'd expect from an alien probe. Not shining lights, not beaming messages, but where? Tear, residue, the scars of its journey. If 3I Atlas is artificial, maybe we've already caught its fingerprints in the form of nickel dust scattered into the void. The imagery is irresistible, a ship gliding through the black ocean of space invisible except for the faint glint of an oil slick trailing behind it. A trace that betrays its passage. That's what the nickel line feels like, a chemical oil slick smeared across the stars. The implications are staggering. If this reading holds, it would mean we've intercepted not just a rock from another system, but evidence of metallurgy, something forged, something engineered. A civilization's signature hiding in plain sight in the spectrum of light. Of course, extraordinary claims demand extraordinary evidence. That mantra hasn't changed. Teams are scrambling to gather more spectroscopic data to confirm or disprove the nickel reading. Instruments like the James Webb Space Telescope and ground-based observatories are on alert. But no matter how the debate ends, the fact remains the initial evidence shook astronomers because it broke a rule that was never supposed to break. This is why Atlas keeps people awake at night. It's not just big, not just aligned, not just stable. It leaves behind chemical fingerprints that whisper of fire and forge of technology riding in the dark. So ask yourself, If you found pure nickel drifting in the coma of an interstellar object, what would you think a natural miracle, or the first industrial footprint humanity has ever detected beyond the solar system? For now, the truth is suspended between caution and wonder. But one thing is certain, the nickel without iron is not silence, it's a voice. Whether it's nature surprising us or something else entirely it's speaking, the question is, are we ready to listen? Every time astronomers measure 3i Atlas, the same word comes back: enormous. Not unusual, not large, enormous. Let's put the numbers on the table. Based on the limits set by thousands of observations, the diameter of 3i Atlas must be at least 5 kilometers across. That's the minimum, the floor. It could be much larger, 20, even 40 kilometers, depending on how dense it is. And when you translate that into mass, you land on a staggering figure, 33 billion tons or more. That number is almost meaningless until you compare it to something we know. Mount Everest, the tallest mountain on Earth, weighs in around 350 trillion pounds. 3i Atlas could rival that. Manhattan Island is just over 20 kilometers long. Atlas could be nearly twice that. If Oumuamua was a pebble and Borisov was a boulder, Atlas is a continent drifting through space. And that scale matters because interstellar objects aren't supposed to be this big. The reservoirs of rock and ice orbiting other stars don't easily throw out giants. The bigger the object, the harder it is for gravity to fling it free. Statistically, if we see one Atlas, we should have seen hundreds of smaller cousins first. That's how the math works. But we didn't. In fact, we've only seen 2 before it, Oumuamua and Borisov, and neither was anywhere near this size. So why now? Why does our third interstellar visitor just happen to be a monster? It's like fishing in the open ocean, casting your net for the first time and pulling up a whale instead of a minnow. The odds defy reason. This is where astronomers start to sweat. Because the sheer bulk of Atlas helps explain some of its other mysteries. If it's this massive, maybe that's why its non-gravitational acceleration looks non-existent. The gas jets can't move it. Its inertia is too great. That's the conservative interpretation. But if that's true, then we're forced into another uncomfortable question. How can such a massive object exist as a free traveller from another system? It shouldn't. Our models don't predict it. The universe isn't supposed to make rocks this big and then casually toss them into interstellar space, unless something wanted us to see it. That's the dangerous thought, the whisper behind the data. Because the bigger the object, the rarer it should be. And yet in less than 10 years of systematic sky surveys, we've seen 3 interstellar visitors, one of which is so large it bends probability out of shape. Maybe our technology just got good enough. Maybe we're finally able to see what was always there. Or maybe we're witnessing something more deliberate. There's another angle here. If Atlas is really 20 or 40 kilometers across, the consequences of a close pass with Earth would be catastrophic. We're talking about extinction level, the kind of impact that ended the age of the dinosaurs. Thankfully, Atlas isn't on a collision course, but the fact that it even brushes our neighbourhood at this scale is enough to remind us how fragile our planet is in the face of cosmic giants. And that scale forces another realization. Oumuamua was small, fast and mysterious. Borisov was smaller still, but more conventional. Atlas is the opposite. Big, heavy, impossible to ignore. Each of the 3 is different. Each of the 3 is bizarre in its own way. And each of the 3 arrived in less than a decade. A trio of riddles stacked one on top of another. Astronomers expected we might have to wait tens of thousands of years to see even one. Instead, we've seen 3 in a single human lifetime. It's not just unusual, it's suspicious. So the question hangs over the night sky. Why is Atlas so big? Why did our cosmic net catch a whale instead of a swarm of minnows? Is this a freak of statistics? Or is there a reason hidden in the shadows for why a 33 billion ton object just happened to pass by right now? That's the weight of Atlas. Not just in tons, but in meaning. Every kilometre of its bulk presses on our understanding of the universe. Every calculation strains against what we thought was possible. And every night it drifts across the stars, it reminds us this is not normal. For centuries, comets were omens, harbingers of change. Today we like to think we've outgrown that superstition. But when a visitor the size of a small city crosses our system carrying mysteries, we can't yet solve the ancient instinct returns. We look up and we wonder, is this chaos or is this code? This isn't the first time we've been surprised by a visitor from the stars. In fact, 3I Atlas is only the latest chapter in a story that has been unfolding for less than a decade, a story that's already shaken astronomy to its core. The first act began in October 2017. Astronomers in Hawaii spotted a faint, fast-moving object crossing the sky. At first, it looked like a comet, but then the data told a different story. Its speed was too high, its trajectory too sharp. This object wasn't bound to the sun at all. It had come from beyond our solar system. Humanity's first confirmed interstellar visitor. They named it Oumuamua Hawaiian for scout or messenger. From the beginning, Oumuamua refused to behave. It was elongated, perhaps cigar-shaped, perhaps more like a pancake depending on how you interpreted the data. No comet had ever looked like it. Stranger still, as it left the solar system, it accelerated. Something was pushing it. But when astronomers searched for the telltale signs of outgassing jets of vapor that would explain the acceleration, they found nothing. No coma, no tail, no evaporation, nothing. It was like a car speeding up without an engine. Oumuamua became a lightning rod. Some said it was just a rock with unusual properties. Others, including Harvard astrophysicist Avi Loeb, suggested it could be technology, maybe a light sail or a probe. The debate raged and still rages today. What was clear is that the universe had handed us a puzzle we weren't ready to solve. 2 years later, Act 2 began. In 2019, a Ukrainian amateur astronomer named Gennady Borisov spotted another interstellar object. It was quickly confirmed and named 2I Borisov. Unlike Oumuamua, Borisov looked more familiar. It had a coma, a tail, the messy outgassing we expect from comets. In many ways, it was normal, but it wasn't entirely. Its chemistry was odd. Spectra showed high levels of carbon monoxide, higher than in typical comets from our solar system. Still, compared to Oumuamua, Borisov felt like reassurance, proof that not every interstellar visitor had to break the rules. Then came 2025, Act 3, and with it 3I Atlas. Atlas doesn't just bend the rules, it crushes them. Where Oumuamua was small and fast, Atlas is massive and steady. Where Borisov was familiar, Atlas is alien. At 5 kilometers across or more, weighing in at tens of billions of tons, it dwarfs both of its predecessors. Its orbit lines up eerily well with the plane of the planets. Its non-gravitational acceleration is practically non-existent despite visible outgassing. And its chemical fingerprint includes nickel without iron, a signature that screams manufactured rather than natural. The sequence is undeniable. 3 objects, 3 anomalies, each stranger than the last. Think about the odds. Before 2017, not a single interstellar object had ever been confirmed. Our model said we might have to wait thousands, even tens of thousands of years before one happened to cross our skies. Instead, we got 3 in less than a decade. 3 visitors in the blink of an eye by cosmic standards. It feels less like random luck, more like a pattern, a drumbeat, a message. When you line them up, the escalation is clear. Oumuamua was a whisper, small, fleeting gone before we could truly study it. Borisov was a reassurance, a comet that fit at least partially into the box of normal. But Atlas is something else. A roar, a statement, a 33 billion-ton enigma hanging in our sky. For astronomers, this backstory is critical. Because Atlas isn't just bizarre on its own, it's bizarre in context. It arrives as part of a sequence of interstellar guests, each rewriting the rules of what's possible. Oumuamua said, "Expect the unexpected." Borisov said, "Don't relax too much." And Atlas says you haven't seen anything yet. It's easy to look at Atlas in isolation and wonder if we're just reading too much into it. But place it in this chain of visitors, and the picture sharpens. This isn't an isolated oddity. It's the latest step in a pattern that has been building one object at a time toward a bigger revelation. Which raises the obvious question, If 3 anomalies can show up in less than 10 years, what else is out there? How many more scouts, messengers, or travellers are on their way? And when they arrive, will they be bigger, stranger, more obvious in their intentions? The backstory matters because it changes how we see Atlas. Alone, it's an oddity. In sequence, it's a crescendo, a note in a rising symphony of interstellar mysteries. And so when we ask what 3i Atlas really is, chaos or code, we have to remember that we've already had practice with this question. We asked it in 2017, we asked it again in 2019, and now here we are asking it once more. But this time the visitor isn't subtle, it isn't small, it isn't easy to dismiss. This time the visitor is a giant. In astronomy, chance usually explains everything. Rocks drift, comets wander, orbits tilt. The universe is messy, chaotic, random. But when astronomers mapped the trajectory of 3i Atlas, something didn't feel random at all. Instead of barreling in on a steep angle the way most interstellar debris would, Atlas arrived on a path perfectly aligned with the flat disk where all of our planets orbit the Sun. The ecliptic plane, Earth, Mars, Jupiter, every planet you can name circles in that same thin slice of space, and Atlas slides right into it like it belongs there. What are the odds? About 1 in 500. Not impossible, but so unlikely that it makes you pause. Imagine throwing a dart blindfolded across a crowded bar and hitting the bullseye dead center. That's Atlas, a traveller from the stars threading a cosmic needle with uncanny precision. Compare that to Oumuamua, its orbit cut across the solar system at a steep angle, no alignment with the planets at all. Borisov too came in on a tilted path. That's what we expect. Random objects arrive on random angles. But Atlas plays by different rules. It moves as if someone charted its course, steering it into the same highway our worlds travel. The metaphor astronomers keep coming back to is this: a dart thrown across the galaxy that just happens to land on the thin vinyl of a spinning record. Space is three-dimensional. Interstellar debris should come from anywhere at any inclination. To land exactly in the planetary plane is not normal. It looks intentional. Now there are natural ways to explain it. Galactic dynamics can funnel interstellar objects along preferred planes. Gravitational tides can nudge trajectories into alignments. But again, probability is the key. When you only have 3 interstellar objects on record and one of them just happens to be the bullseye case, the suspicion grows, especially when that same object also happens to be the biggest, the heaviest, the most stable, and the most chemically bizarre. This is why Atlas keeps stacking up as an anomaly. It's not just one odd feature, it's the combination: size, stability, chemistry, and now orbit. Each layer builds the case that this is not simply a rock drifting by. It's something different. Think about what alignment implies. If you were sending a probe into a planetary system, you wouldn't come in on a random angle. You'd want to maximize your chances of close encounters with planets. You'd want to scan worlds, measure atmospheres, maybe even observe life. The most efficient way to do that is to follow the same plane where the planets are. That's the highway of the solar system, and Atlas is driving right down it. Is it coincidence? Or is it navigation skeptics reminders of the numbers? 1 in 500 is rare but not impossible. Roll the dice often enough and strange outcomes appear. The problem is we haven't been rolling for very long. Modern surveys have only been watching the sky carefully for a decade or two. In that short span, we've already seen anomalies piling up. Oumuamua with its unexplained acceleration, Borisov with its odd chemistry. And now Atlas aligned like it had a destination in mind. It feels less like a roll of the dice, more like a pattern written into the sky. And patterns make us uneasy. Because when nature looks deliberate, the human mind leaps to the word we all avoid: design. Design doesn't mean certainty. It doesn't mean alien spacecraft hiding in plain sight. But it does mean the line between coincidence and control has blurred. And the closer Atlas sticks to the ecliptic, the harder that blur is to ignore. Imagine watching a dart thrown not across a bar but across the galaxy. It arcs through billions of stars past dust clouds and magnetic fields, and lands squarely in the same thin lane where Earth itself travels. That's the shot we're watching right now, a cosmic dart, a perfect aim. If Atlas were just a random rock, its orbit should feel random too. Instead, it feels rehearsed, calculated, chosen, and that feeling gnaws at scientists every time they run the models. So here's the lingering question. Did Atlas stumble into the solar system by luck, or did it follow a script? Did galactic tides and chance alignments guide it here, or was it programmed long ago, far away, to pass through the planetary plane? Because if this was just chaos, it's chaos wearing the mask of order. And if it was code, then we're not just looking at a rock, we're looking at a message. Was 3i Atlas simply drifting, or was it set on course? Was this alignment a fluke of nature, or was it planned? In other words, was this object always meant to come here? Was it programmed to stop by? To understand why 3i Atlas feels so unsettling, we need to rewind to the first time humanity met a traveller from the stars, back to 2017, back to Oumuamua. Oumuamua was tiny compared to Atlas, barely a football field in length, maybe 200 or 300 meters across depending on how you model it. A sliver of rock compared to the mountain we face today. But what it lacked in size, it made up for in mystery. It entered our solar system on a steep, unexpected angle, racing faster than any natural asteroid we'd ever tracked. Its shape was bizarre, so elongated it resembled a cigar or a pancake depending on the data. But the real shock came after it passed the sun. Instead of slowing down the way gravity dictated, Oumuamua sped up. It accelerated. Something pushed it. And yet there was no sign of outgassing, no jets of vapour, no coma, no tail, nothing. The usual explanation for a comet's acceleration didn't exist here. Oumuamua defied the rules, a rock that behaved like a spacecraft without showing its engine. Now fast forward to 2025. 3i Atlas, the opposite extreme. Where Oumuamua was small and light, Atlas is massive and heavy. Where Oumuamua tumbled and twisted, Atlas glides steady and stable. Where Oumuamua accelerated too much, Atlas refuses to accelerate at all. They are mirror images, two ends of a spectrum, and yet they share one critical trait, both break the rules of nature. Oumuamua accelerated when it shouldn't have. Atlas refuses to accelerate when it should. Both are contradictions. Both are anomalies. Seen alone, each one is an oddity. Strange, yes, but maybe just a fluke. Seen together, they look like a pattern. Two different visitors years apart, showing us that interstellar objects don't play by the script we wrote for them. This is where the human brain kicks into overdrive. We're wired to connect dots, to find meaning in the noise. And when we line up Oumuamua and Atlas, the dots are hard to ignore. Both appear unnatural. Both invite the question, are we looking at chaos or code? Think about the contrast. Oumuamua was so light it could have been a fragment, a sail, maybe even a sheet of material thin enough to ride sunlight. Atlas is so heavy it might be immune to the very forces that shape comets. Oumuamua zipped past before we could study it closely, gone in weeks. Atlas lingers, giving us months, even years to watch. They are different in every measurable way except one they don't belong. And maybe that's the point. Maybe interstellar visitors will always look strange because they come from places we don't understand. Or maybe they look strange because some of them aren't random rocks at all. Maybe some are probes. Maybe some are scouts. Maybe some are built. Oumuamua was our first whisper. Atlas is our latest roar. And in between, Borisov gave us a false sense of normalcy, a comet that behaved more or less the way we expected. But now the pendulum swings back, from too fast to too steady, from too light to too heavy, from inexplicable acceleration to inexplicable stability. What's the common thread? They both stretch our models to the breaking point. They both suggest that interstellar space is delivering objects we don't know how to categorize. And they both challenge the line between nature and technology. This is why scientists like Avi Loeb push the conversation further. Oumuamua may have been a light sail, he suggests. Atlas may be something even more deliberate. Two very different objects, one unsettling conclusion. For the public, the comparisons are irresistible. A sliver of rock that's sped up without gas, a mountain of ice and metal that refuses to budge despite gas. Both scream impossible. Both scream pay attention. And that's the deeper story here. Oumuamua was not an isolated anomaly. Atlas is not an isolated anomaly. Together they feel like bookends on a shelf we've only just discovered. A library of visitors from the stars, each volume stranger than the last. So when you think of Atlas, don't think of it as just another comet. Think of it in the shadow of Oumuamua. One too light, one too heavy. One too fast, one too steady. Both too strange to dismiss. Because when anomalies start to rhyme, they stop feeling like coincidences. They start feeling like code. If Three-Eye Atlas is a riddle, then astronomers are detectives and the telescopes of Earth and space are their magnifying glasses. Every strange clue Atlas has given us, its impossible size, its strange chemistry, its steady course only sharpens the hunt. The question now is simple. How do we catch it in the act? That's where the eyes of modern astronomy come in. Spread across the globe and orbiting far above our planet, these instruments are not just cameras. They are forensic tools designed to peel away layers of mystery one wavelength at a time. And now all of them are trained on a single target. Start with the James Webb Space Telescope. Floating nearly 1 million miles from Earth, Webb sees in infrared the spectrum of heat. That means it can catch faint signatures of gases venting from Atlas, distinguish between carbon dioxide, carbon monoxide, even trace amounts of cyanide. Webb is the bloodhound in this case, sniffing out chemical fingerprints invisible to human eyes. Its data has already raised eyebrows, confirming the presence of nickel without iron. But Webb is just one detective on the team. Then there's Hubble. Launched more than 3 decades ago, still going strong. Hubble's sharp vision in visible light makes it the perfect witness for brightness changes and outgassing plumes. It can track Atlas's glow as it rises and falls, measure its tail, and compare its behavior to every comet ever recorded. Where Webb delivers chemistry, Hubble delivers behavior. Together they paint a fuller picture. But the most intriguing eye may not even be Earth-based. Orbiting Mars, the Mars Reconnaissance Orbiter carries a high-resolution camera, high-rise, capable of astonishing detail. On October 3rd, 2025, that camera will get a shot at Atlas from a unique angle. For the first time, we may see not just light curves, not just spectra, but an actual image of the interstellar visitor itself. A pixel or two, maybe more. But in that pixel lies truth. If Atlas is larger than 5 kilometers, if it shows structure beyond what a natural body should high-rise, might capture the first visual evidence of something beyond chance. Mark the calendar. October 3rd, the first big moment. The second comes weeks later, on October 29th, 2025. Atlas will swing close to the Sun. Normally this is when comets put on their show. Gas erupts, tails flare, paths bend under the pressure of solar heating. If Atlas follows the rules, we'll see it then. But if it holds its line steady and unnatural, the mystery deepens. Observatories worldwide are preparing. This is the courtroom moment when the witness either confirms the story or blows it apart. And then comes the third date, March 16th, 2026. Atlas will pass close to Jupiter. That giant planet with its massive gravity will pull on the visitor and test its resilience. Will Atlas bend to nature's will, or will it shrug off even Jupiter's grasp as if on rails of its own making? By then the evidence will be overwhelming one way or another. 3 dates, 3 chances to catch the truth. Astronomers describe it like a detective story. Each observation is a clue. Each spectrum, each brightness curve, each image is a fingerprint. And together they will reveal whether Atlas is a comet unlike any we've ever seen, or something built. But the mood is tense, because this investigation is unfolding live. We aren't reading about history, we're watching it happen. Each night observatories across the world, over 200 of them, track the faint speck. Computers crunch terabytes of data comparing Atlas to every known comet and asteroid. And with each new data set, the question grows sharper: chaos or code? There's a thrill in this hunt. but also unease. Because detectives don't always like the answers they find. Sometimes the evidence points to places you never wanted to go. And yet that's what science demands. Follow the data, collect the clues, build the case. Atlas isn't giving up its secrets easily, but it cannot hide forever. Not from Webb, not from Hubble, not from Mars. So picture it this way. Humanity is standing in a cosmic crime scene. A 33 billion-ton suspect drifts silently through the solar system. The instruments are out, the witnesses are testifying, and every observation brings us closer to the verdict. Will it be guilty of nothing more than being a freak of nature, or guilty of being something we've never seen before, a visitor not just from another star, but from another mind by March 2026? We may know. Until then, the chase is on. So far, we've followed the trail of mysteries that make 3i Atlas look engineered. The impossible size, the steady course, the strange chemistry, the eerie orbit. But let's step back for a moment. What if all of this really is natural? What if Atlas is not a probe or a ship, but a comet, just a comet born in the chaos of another star system? That possibility cannot be dismissed. Extraordinary claims require extraordinary evidence, and science is built on restraint. The most conservative answer is always the starting point. So let's imagine Atlas as a natural body. In that case, what kind of comet are we looking at? The answer would be a giant. A survivor from the deep freeze at the edge of some distant solar system, perhaps from an Oort cloud-like reservoir surrounding another star. These clouds contain trillions of icy bodies, most too small to ever escape their parent star's gravity. But occasionally a close pass by another star or the tidal forces of the galaxy can sling one outward. It drifts lightless and cold for millions of years, until by sheer chance it crosses ours. If Atlas is that kind of body, then it forces us to rewrite the models. Because according to our current understanding, objects of this size, 5, 10, maybe even 40 kilometers across, should be almost impossible to eject. They are too massive, too deeply bound by gravity to be flung free. Smaller bodies, yes. Pebbles, boulders, even mountains, those we expect. But a whale-sized object that's rare to the point of absurdity. And yet here Atlas is. Which means our models of planetary formation and interstellar ejection are incomplete. Maybe other star systems are more violent than we thought. Maybe collisions, migrations, or unstable orbits hurl out giants more often than our simulations predict. If Atlas is natural, it is telling us that our picture of how solar systems evolve is wrong. That alone would be revolutionary. Imagine textbooks rewritten, entire courses in astrophysics updated, a single comet forcing humanity to rethink the architecture of planets, stars, and the debris that circles them. And then there is the chemistry. Nickel without iron. If natural, this means exotic processes are at play in distant star systems. Conditions unlike anything we've seen in our own. Maybe alien volcanism, maybe supernova remnants with unusual yields. Whatever the cause, it would expand the boundaries of what's possible in cosmic chemistry. Again, chaos not code, but chaos with profound lessons. So even if we strip away the allure of alien technology, Atlas still stands as one of the most important discoveries of the century. It challenges our models of size distribution of orbital mechanics of chemistry. It shows us that the galaxy is stranger than we assumed. And that's the point. Natural doesn't mean boring. Natural can still be shocking. Natural can still break our understanding and force us to grow. Remember how we reacted to Oumuamua? For many, the alien explanation was tempting. But even if it was just a rock, it was still a first. The first confirmed interstellar object. A landmark discovery. Atlas. If natural plays the same role, only louder. It's telling us you don't know the galaxy as well as you think. There is also comfort in the natural explanation. If Atlas is a comet, however bizarre, then the universe remains indifferent. No message, no probe, no hidden agenda. Just rocks and ice drifting as they always have. For some, that's less thrilling but safer. For others, it's equally profound proof that cosmic diversity is wider than our narrow expectations. So what's the takeaway? If Atlas is natural, it is still extraordinary. It means the galaxy manufactures giants more often than we thought. It means interstellar visitors are not just possible, but inevitable. It means our cosmic backyard is more crowded than we ever dreamed. Chaos doesn't lessen the wonder. Chaos deepens it. Because if the universe can fling a 33 billion ton traveller into our skies by accident, then the universe is far more powerful, far more creative, and far more unpredictable than we imagined. So whether Atlas is code or chaos machine or comet, the message is the same. We have more to learn, and the night sky is not as quiet as we once believed. What if all the whispers are true? What if 3 Atlas isn't just a rock or a comet, but something else entirely? Something built, something designed. Imagine it. A 33 billion ton craft older than our civilization, older than our species, gliding silently into our solar system. No signal, no announcement, no lights flashing in the dark. Just mass chemistry and physics that refuse to behave. What would that mean? For the first time in history, humanity would no longer be guessing about whether we're alone. We would know. Not from radio signals that could be dismissed as noise, not from blurry lights in the sky, but from a physical object, hard evidence passing right through our cosmic backyard. The comparisons are unavoidable. When we sent out Voyager and Pioneer, we knew we were flinging messages into the abyss. Small fragile probes carrying plaques and golden records, hoping that someone someday might find them. They are humanity's calling cards, our proof of existence. Now flip the perspective. What if 3i Atlas is their version of Voyager, their proof, their calling card, a silent ambassador moving on a path set millions of years ago, finally intersecting with us? But the differences are staggering. Our Voyagers are tiny, about the size of a small car weighing less than a ton. Atlas is colossal, a mountain compared to our pebble. If it is a probe, it is not a message in a bottle. It is an ark, a fortress, a leviathan designed to survive eons between the stars. And that raises terrifying, thrilling questions. Was it meant to be found, or was it never meant for us at all? Is it drifting because its mission is long over, or is this moment now exactly what it was built for? The implications ripple through every part of human life. Politically, nations would scramble. Who gets to claim contact? Who has the authority to study or even approach something like Atlas? Space agencies would face pressure unlike anything they've ever seen. Alliances could fracture. Rivalries could ignite. The race to interpret, to communicate, to control the narrative would begin immediately. Socially and culturally, the ground would shake. For centuries, religions have speculated about life beyond Earth. Some would see Atlas as proof of divine creation, others as a challenge to dogma. Philosophers would wrestle with questions of purpose. If we are not alone, what does that make us, a young civilization staring up at our elders, or a species about to join a galactic community? Economically, the stakes would be incalculable. A craft of that size could contain materials, technologies, and knowledge beyond our imagination. Just the hint of alien metallurgy, nickel without iron, already sends shivers through industry. What if inside Atlas lies an understanding of energy propulsion, or even consciousness itself? Companies, governments, militaries, all would want a piece. And then there's the psychological weight. Humanity's self-image has always rested on the idea that we are unique, special, the only intelligent life we know. If Atlas is artificial, the delusion shatters. Overnight, we go from being the smartest creatures we know to realizing we're not even close. The emotional impact would be indescribable. Awe, fear, wonder, anxiety, hope. For some, it would be the greatest revelation in history. For others, the greatest threat. Now picture the extremes. If Atlas is a probe, maybe it's just observing, watching from a distance, recording data the way Voyager does when it passes a planet. But if it's more than that, if it's a signal or even a relic of a civilization long gone, then its very existence tells us we're part of a story far older and far bigger than ourselves. And here's the thought that keeps people awake at night. What if it's not abandoned? What if it's active? What if the lack of visible acceleration, the perfect orbit, The strange chemistry are not just relics but functions, signs of an intelligence still guiding it right now. The idea is almost unbearable, but it is also irresistible. Because deep down, this is the question we've been asking since the first human looked up. At the stars, are we alone? Atlas might be the answer. If it is code, not chaos, if it is design, not accident, then humanity will never be the same. Our science will leap forward. Our religions will transform. Our politics will scramble. Our art, our philosophy, our sense of meaning, all will shift. Because once you know you're not alone, you can never unknow it. The day we confirm Atlas as artificial would be the day the story of humanity splits in two. Everything before and everything after. And that's why this moment feels like standing on the edge of a cliff. We can't yet see the bottom. We don't know how far the drop goes. But we know that if Atlas is truly a machine, truly a probe, then the leap into the unknown is coming. If this is chaos, then the universe has surprised us again with its randomness. But if this is code, if 3i Atlas is alien technology gliding silently past our world, then humanity will never be the same. Because the difference between chaos and code isn't just academic. The difference changes everything. Now we've walked through every clue. The mass, the orbit, the strange chemistry, the impossible physics. We've looked at Atlas as a comet, a machine, a message. And now standing at the end of this investigation, we face the choice that has haunted every frame of this story. Chaos or code. On one side stands chaos, the idea that Atlas is a freak of nature, a monster comet flung out of another star system bigger than anything our models predicted. A body that just happens to be aligned with the planetary plane, just happens to show nickel without iron, just happens to glide without measurable acceleration. Unlikely, yes, but not impossible. Nature is vast, probability is cruel, and sometimes the dice come up strange. If this is chaos, then Atlas is still extraordinary. It would force us to rewrite our understanding of how solar systems form and evolve. It would prove that the universe is capable of surprises on a scale we never imagined. On the other side stands code, the idea that Atlas is not random at all but deliberate, that its orbit is chosen, its stability controlled, its chemistry engineered, that the nickel in its halo is not a quirk of nature but a scar of technology, that the absence of non-gravitational acceleration is not mass alone but intention. If this is code, then Atlas is not just a comet. It's a probe, a messenger, a vessel of another civilization drifting silently into our skies. Both answers change everything. If it's chaos, the universe is far stranger than we thought. Our textbooks crumble, our models collapse. We are forced to rebuild our picture of the galaxy from the ground up. And that in itself is thrilling. Chaos would tell us that the cosmos is endlessly inventive, endlessly capable of breaking our expectations, that we should never assume we've seen it all. If it's code, the implications are deeper still. It would mean we are not alone. That intelligence is not unique to Earth, that somewhere out there others have built, engineered, travelled, and that they left behind artifacts large enough to cross the void and find us. Code would not just rewrite science, it would rewrite humanity. The evidence doesn't settle the question, it only sharpens it. Each anomaly pushes us towards suspicion, but suspicion is not proof. Each explanation offers safety, but safety is not certainty. The truth hangs between the two poles, waiting for more data, more images, more time, and maybe that's the real lesson. That science is not about answers carved in stone. It's about questions, about following the trail no matter where it leads, about refusing to look away even when the possibilities are unsettling. Atlas is still out there cutting across the darkness, heading for its close pass by Jupiter. Telescopes are watching. Spacecraft are listening. The investigation is far from over. But for now, all we can do is stare upward and wonder. Is this chaos, a random traveller, a freak born of natural violence reminding us of how little we know? Or is this code, a design, a message, a whisper, across the stars from minds older than our own? The answer is not here yet. It may come tomorrow, or next year, or never. But the question itself has already changed us. Because once you've asked whether a mountain of metal and ice drifting through your sky is natural or artificial, you can never go back to the comfort of certainty. So here we are, suspended between chaos and code, between chance and intention, between solitude and company. The only thing left is to keep looking up, to keep watching, to keep asking. Because the truth is still out there written in the light of a faint interstellar visitor. And maybe the truth is that the universe is far more alive, far more mysterious, and far more extraordinary than we ever dared to believe. The answer is not here. But the question is ours to carry, and it will keep us staring at the stars,